My dear students, welcome to Education Hub. Today we shall discuss the last concept of your class 10th mathematics from the concept of real numbers. The concept is deals about the first of all we will discuss about the rational number and the decimal expansions of rational number. First of all we shall discuss what is rational number. The rational number is a number which can be represented in the form of p by q, where q not equals to 0. Understand what I am saying? A rational number is a number which we can represent in the form of p by q, where q is not equals to 0. Then here we shall discuss the decimal expansion or the decimal form of the rational number. What is the decimal? Generally, whenever we are discussing the 1 by 10th form, means we are going to the decimals form. Then if will be divided as one part into 10 parts. Let's say this is a part. If I divide into them, if I say the entire one is the one part, and if I divide into this part into the 10 equal parts, let's take this is a part 2, 3, 4, 5, 6, 7. Let's think this is 8, 9, and 10. Let's think the entire part divided into 10 equal parts. Each part will be the 1 by 10 part, and this is the 0.1. Means whenever the 1 and 0 is there, means here 1 0 in the denominator part, and if it is 1 here, then we can use the decimal and put the number 1 to the right of the decimal. This is the form which we can represent in the decimal form. Here the every rational number we can represent to the decimal form, but there is some numbers are some numbers are classified into them. If let's in simplified form, I can say in decimal numbers we can see there's lot of decimal numbers are there, but if we can classify into different format, then each rational number can be expressed in the decimal form in these kind of decimal expansions. What are these kinds of decimal expansions? Let's see. The decimal expansion can be terminating or non-terminating. What is terminating? You already know terminate means end. Means any decimal expansion, if there will be end will happen. Example, if I say the number 1 by 2. As we know, this 1 by 2, we can find the decimal in the form of decimal. Just how we will find? We will multiply the 5 numerator and denominator. This will be 5 by 10. This will be 0.5. Okay. If I say 1 by 4, if I multiply 25 with the 25, what I will find? What I will get? 25 by 100. And this will be 0.25. In the same way, here every number what you will write, all are, if at a certain point of time the number will be end, then this is called the terminating. If I write the 1 by 3, here see this will be 0.3333. Understand? Here the number will be continue as long as we will continue the division. Then this is a non-terminating. Hence this non-terminating is again divided into two types. First is recurring. Next is non-recurring. Example, the recurring means which will repeat the same number continuously. Example, if I'll find the decimal expansion of 1 by 7, you will get 0.14285 bar. Bar means the same number will repeat again and again. Okay. If I write the 1 by 9, this will be 0.010101 in such way. Here, these all are the recurring numbers. Means each number will be repeat again and again. But in case of non-recurring, it will not end, as it is non-terminating and non-recurring. That means a decimal number which never terminate, means it never stops, and it so long it will continue. And the another thing, it won't be repeat, means the same number we cannot get the repeatedly. That's why this is called the non-recurring. Means what we understood, the decimal expansion can be broadly classified into two types. One is terminating and non-terminating. The terminating, then this will be at any point of time the number will end. But in non-terminating, at any point of time it never ends. And second thing, if it will be non-terminating, it never ends. And second thing, if it will continue. And if it will continue, whether it will continue repeatedly or non-repeatedly. If it will repeatedly, this is recurring. If it will not continue repeatedly, this is non-recurring. Generally, if you say the rational number, we can say terminating decimal expansion, and non-terminating recurring decimal expansion is said to be the rational number, and non-terminating non-recurring decimal expansion is said to be the irrational number, and the entire numbers are under the real numbers. Now let's move into some of the basic concepts which are truly involved or useful for our concept. Let's see what are the basic concepts. See, first basic concept is that, let's take the two numbers, I will say x and y. Let's take the two numbers, I will say x and y. We have to find a rational number in between the x and y. Then what is our formula? X plus y by 2. This is the formula to find the rational number in between the x and y. But what is the formula to find the irrational number in between the x and y? It is a rational number in between x and y, or rational numbers which will find between the x and y. To find the irrational number between the x and y, that is the root xy. Root xy is the irrational number in between x and y. Remember, this is the most important. It may be helpful for your future in any mathematical concepts. And first concept. Second is that if you will take a irrational number and I will take another irrational number, if we will add or subtract, the result may be rational or irrational. Why? Because let's take, I will take the root 2 and I will take another root 2. If I will add, this will be 2 root 2. If I will subtract, then this will be 0. 0 is a rational number, whereas 2 root 2 is a irrational number. That's why the addition or subtraction value may be rational, may be irrational. In the same way, if I will take the one irrational number and I will multiply or divide with another irrational number, the value may be rational, may be irrational. Why? Because again the same value, if I will take root 2, I will multiply with the root 2, this will be 2. But whereas if I will take root 2 and I will take another root 3, if I multiply, the value is the root 6. In this case, this is the rational and this is the irrational. In the same way, if I take the root 2 and divide with the root 2, this may be 1, this is the irrational, sorry, this is the rational. If I multiply, if I take root 2, I will divide with the root 3, the value is the 2 by 3. This is irrational. That's why the multiplication value or the division value may be rational, may be irrational. But in the case of rational, if you take the two rational numbers, if you multiply or add, subtract or divide, all the value at any time, you will get the rational value only. Understand, my dear students? Now, basing on these ideas, we will continue to some more concepts of the decimal expansion. Now first of all, we will discuss the three most important theorem in your textbook. Then we shall continue the other concepts of your textbook. And in addition to this, we will continue today about some of the doubts which, since now I had given some of the questions to you, we shall discuss that questions also. Now see, dear students, this is the theorem of your last exercise. There are two more theorems apart from this one. First of all, we shall discuss this theorem. Let x be a rational number whose decimal expansion terminates, then x can be expressed in the form of p by q, where p, q are co-primes and the prime factorization of q is of the form 2 power n pi power m, where n and m are non-negative integers. What that means? Actually, I said first of all we'll discuss one by one briefly. Let x be a rational number, means x is the one number which is a rational number. What is that value? We don't know. Okay, let's take we don't know there is a number. X is a decimal number whose decimal expansion terminates. I will take the one example. X is the 23.408. Means this is a number whose decimal expansion terminates. Then x can be expressed in the form of p by q. Means this x can be expressed in the form of p by q. Means x equal to 23408 or 23,408 by 1000. How it comes to 1000? Because after the decimal is the short form is that after the decimal there is 3 digits are there. I will put in the denominator 1 after 3 zeros. This is a short form of the short trick we can use to remember. Now the number will be 23,408 by 1000. Means up to this much we understood. Let x be a rational number. Now x be a rational number whose decimal expansion terminates. Because the 8 is the last term, the last number for this decimal expansion. Then x can be expressed in the form of p by q. Now I expressed this in the form of p by q, where p and q are co-primes. What is co-primes here? Here the 23,408 and 1000 should have the common factor as 1. But in the actual case here, the co-prime, it is not the co-prime. If we will divide the continuously the number, then we will get a reduced form of this fraction. That means what? We will get the p by q, which are the co-primes. Means they have the only one common factor, that is 1. There's no common factors for that. But here some more common factors are there. But for time being, now we will discuss something. Are co-primes and the prime factorization of q is of the form 2 power n pi power m. Means now we should not discuss about this number. Now we shall discuss about the q. This is the q. If we will take the q, if I will be represent in the form of 2 power n and pi power m. What is n and m here? Here n and m are non-negative integers. Non-negative integers means n should not be 0 and m should not be 0. Means n and m may be equal, may not be equal. But here what will represent? Q is the 1000. Then this will be 10 power 3. This will be 2 into 5 power 3. This is 2 power 3 into 5 power 3. See here n is the 3 and m is the 3. Both are equal. That's not a topic for discussion. Here n and m both are non-negative integers. That is the point of discussion. As here given, n and m are non-negative integers. Means it satisfied n is not 0, m also not 0. And it is also in the form of 2 power n into 5 power m. Which one? The q1. That's why this is the entirely, this x is the rational number. Means only one condition will be satisfied when x is a rational number and x can be represented in the form of p by q, where p and q are the prime factors. Then this q will be represented in the form of 2 power n into 5 power m. This is what about our first theorem of this exercise. Now we shall move to the second theorem of this exercise. Now we shall discuss the second theorem of this exercise, or the fourth theorem of this chapter. What is this theorem? This theorem says that let x equal to p by q be a rational number. Means here already said you that x is a rational number which is on the form of p by q, such that the prime factorization of q is of the form 2 power n and 5 power m, where n and m are non-negative integers. Then x has a decimal expansion which terminates. What that means? You can clearly see here one number is given, that is the x, that is x is p by q, means let's take the x is a number which is also the rational number, and this rational number is in the form of p by q. Let's take this is the 13 by 125. I took the number as 13 by 125, and here it is given so that the prime factorization of q is of the form 2 power n 5 power m. It is the prime factorization of q. Here the q is the 125. Q is the 125 whose prime factorization is of the form of 2 power n 5 power m. That means what? If I will prime factorize this one, I will get the 5 power 3. As it is a 5 power 3, but here 2 power anything is not there. But we shall, to get the 2 power n 5 power m, what I will do is I will simply multiply 13 by 125 with the 2 power 3, the numerator and denominator. What I will get? I will get 13 into 8 by 125 into 8. Here the value you can clearly write down here. Here 104 by 1000. Then x has a decimal expansion which terminates, means it can be written as the 0.104. Means what it indicates? This x has a decimal expansion which will be terminate. Means if you will divide the 125 by 125 with the 13, the value what you will get? 0.104. And the condition is that the denominator or the q should have in the form of 2 power n into 5 power m, where n and m are the non-negative integers. Here see, you can understand what we done in the last exercise, last theorem. We took the one decimal and then what we get the rational number or the in the form of p by q, and we tested for the q and whether it is in the form of p by q, 2 power n into 5 power m, it was there, and what we get and what here is that which are both the converse to one another. That's why this theorem is alternative, we can say this is the converse of theorem 3. What is this theorem says? Again I'm saying, or the in rough way I am saying, if x is a prime number, if x is a rational number in the form of p by q, where q is in the form of 2 power n into 5 power m, then this entire number can be represented in the form of decimal or the decimal expansion. Understand? Now we will go to the next theorem of this exercise. What is the theorem 5 or the theorem 3 of this exercise? See the third theorem of this exercise or the fifth theorem of this chapter, that is the let x equal to p by q be a rational number. Means here a number is given x. Let take the number is x, which is a rational number, such that the prime factorization of q is not in the form of 2 power n 5 power n. Let take x is the 1 by 13. If I will take this 13 as the q, then what will happen? As q is 13, the prime factorization of 13 not in the form of 2 power n into 5 power m, which is not in the form of 2 power n and 5 power m. That means what? Where n and m are non-negative integers, we got that. Then x has a decimal expansion which is non-terminating repeating. Means if the number is non-terminating repeating also, this is also rational number. Means if I find the value of this 1 by 13, then what will write? 0.076923, 0.076923, like that. That means what? It is the 0.076923 bar. This means this number 0.76923 repeating continuously, or this is a recurring number. Hence this is a number which is not in the form of whenever the q is not in the form of 2 power n and 5 power m, then it is the non-terminating and repeating number. As it is, it never terminates, and that's why, and it also repeats as well. That's why this is also a rational number, and including that this is not in the form of 2 power n 5 power m. Then what we will write here? As here q is uh, is not in the form 2 power n into 5 power m. Hence it non-terminating recurring rational number or the decimal expansion. Hence it is also a rational number. Means a number is a rational number only the two conditions. First of all, it should, the decimal exponent should be terminate, or if it is non-terminating, it always a recurring number. If it is non-recurring, then we can simply say this is not a rational number. Means for a number is rational or not, by using the decimal expansion, we can use for the two theorems, for the theorem 4 and theorem 5. And using these theorems, we can easily solve the fourth exercise of your chapter. And now we'll move to some of the important questions, or some of the questions which I had not said you, which you asked me in the doubts section. Okay, thanking you. Now we'll move to the doubt section. Now we shall discuss some questions of from your doubts. The first question is it possible two numbers have 12 as their HCF and 350 as their LCM? Explain. But the question is, first look to the question. The two numbers, what are the two numbers? We don't know. But we know that, let's take if the two numbers A and B and their HCF is the 12. In the same way, we don't know the two numbers, but the LCM is given. The LCM of the two numbers is the 350. Before going to the answer, just I want to clear one concept for you. Let's take, I will find the HCF and LCM for the 2 and 4. See, if we find the HCF for the 2 and 4, the HCF is the 2 and LCM is the 4. That means what? This HCF and LCM, see, what is the relation between the HCF and LCM? The HCF is always the factor of LCM. Hence, if we can divide this number with this number, if we'll get the remainder as the 0, that means we will understand this number is the factor of this number. In the same way, you can apply the same concept here. If you divide this number with 350, if you get the remainder is a 0, that means you will understand that 12 is the factor of 350. It indicates that then A and B is the HCF is the 12 and A and B is the LCM is the 350. Let me explain. See, if I divide the 350 with the 12, see, 12 to the 24, the 11, this is 0. See, 12 9 is 108 and 12 10 is 120. Then this will be the remainder is the 2. This is not 0. Means it clearly indicates that 12 is not the factor of 350, and hence it is not possible for two numbers which have the HCF as the 12 and LCM as the 350. Therefore, it is not possible. Understand, my students? Now we'll go to the next question from your doubt section. Now, dear student, see, the second question of your doubt section is express the HCF of 468 and 222 as 468x plus 222y, where x, y are integers in two different ways. First of all, what is this question means? The question means that HCF, we have to find the HCF of 468 and 222, but the resultant we have to find the HCF, and this HCF, what is the HCF that we have to find, and that HCF should be represented only in the form of this. And what is the x and y? This x, y are the integers only, and that should be in two different ways. Let's see. First of all, I will find the HCF of 468 and 222. Here see, use the Euclid's division lemma. Here 468 equal to, simply divide 222 with the 468. What will get? 2 is 444. This is 24. Then this will be 222 into 2 plus 24, as here r is not equals to 0, the remainder not equals to 0, then we'll move to the next step where I will take the 222 as the dividend. Now the remainder will be, I will take the remainder as the divisor. Now I will multiply the 24, divide the 24 with the 222. Just use the division method. Now if I will take the 5 here, 5 for the 20, 0 to 5 to the 10 to 12, then what will happen? This will be 120, which can be possible. Means if I will take the double, means 240 will happen. That's why I'll take here 9. What is the value here? 9 for the 36, 3, 9 to the 18, 3, 216. Why I took the 5 initially? The reason is that I use the number, the smallest number, which you can multiply very easily. If I multiply the 5 easily, then you will get the value. So what the value will get? Then if you double the value, then you will understand whether that value is suitable for this or not. As it is not suitable, then you can take the lesser value. Then what is the value you will get here? Here you will get the 6 as the remainder. Then you can write here 24 into 9 plus 6, where remainder is not equals to 0. That's why you have to follow the next step, where 24 is the dividend and 6 is the divisor. Next 6 4 is 24, the remainder is the 0. Hence here this divisor is the H shape. Now this H shape, what is the H shape here? Here the H shape is the 6. As the H shape is the 6, we have to represent this H shape, means 6 into the 468x plus 222y. Understand what the question is? The question is the H shape of 468 into 222 is that 6. This should be represented in the form of the 468x and 222y. For this representation, what I will do? I will do this from the back method. Means what? In the opposite method. Means I will take what is the 6 here. The 6 is here. The 6 is what is 222 minus 24 into 9. 222 minus 24 into 9. Now what is the 24 here? The 24 is the 468 minus 222 into 2. This term will be the left of this term. Will goes to left of the term. Then this will be 222 minus 24. Sorry, 222 minus 468 minus 222 into 2 into 9. Understand what the question here? See, this will be 6 equal to 222 minus 468 into 9 minus 222 into 18. See, now what I did, just I am repeating again. Here what I did, here 6 equal to 468x plus 222y. Sorry, 222y. I have to represent in such a way. For that, what I took the 6 as the H shape. As it is a 6, the left hand side is the fixed one. That's why this is the where I will get the 6 here. I will get the 6 here. What the 6 here? If I will get the 6 here, there is nothing difference, because this is 0 won't be go here. If the 0 will be go here, 24 minus 0 is the 24 only. If here the 4 will go, this will be divided with the 4. Then the value is the 6 only. But here what I will get, 6 equal to 222 minus, if this term will go to the left of this term, left of the equal to, then this will be 222 minus 24 into 9. Now again I will find the 24 value from here. Here what is the 24 here? When this term will go to the left of this equal to 468 minus 222 into 2. Now I will multiply 9 the whole term. Here this will be 468 into 9 minus 222 into 2 into 9 is the 18. Now what I will do, as here minus and minus is there, hence this is the plus. Then this will be 6 equal to 468 into minus 9 plus, as here in these two terms 222 is the common, then this will be 222 into 19. As this is the 1, this will be 1 plus 18, and hence this will be 19. And hence here x is the minus 9, y is the 19. Now this is the one way we got the value of x and y. Now we move to this in the another way. Now we'll see the second method. See, in second method, I will take the same value 6 equal to 468 into minus 9 plus 222 into 19. Here, just I will add the plus 0. Why am I adding the plus 0? To not change the value. As here is a 0, I can add any number and subtract the same number, then the value may not change, because plus 0 means this may be 6 minus 6, this may be 2 minus 2, this may be 1 minus 1. Anything value which is the, if I add the same value and subtract the same value, the value won't be changed. That means what? Here if I add the 6 minus 6, the value is the 0. That's why I added here the 0. If I use this one as a 2 into 3 minus 2 into 3, there will be the value won't be changed. Hence, I will use the value in such a way that our answer we will get in a very correct way. See, 468 into minus 9 plus 222 into 19 plus 468 into 222 minus 468 into 222. See, the same value we added here and the same value we subtracted also here. Now what I will do, I will take 468 as the common for these two terms. Then what will happen into minus 9 plus 222. In the same way, for these two terms, I will take as the 222 as the common. So what I'll get? 19 minus 468. What the value will get? Here, 468 into, if minus 9 will be added with the 222, the value what will get is the 213 plus 222 into, here 19 minus 468, what will get? Here the 4, just I am erasing now this line, minus 449. Hence, here x is the 213, y is the minus 449. Here, in one method, we got the x, the value x and y. In the another method, we got the value x and y. As such, we completed the two doubts which is the most of the persons were asked. Now, I will give another question for you to do as your home task and submit me. See students, this is your question to do as a home task. The question is as like, if a, b, c, k be rational numbers such that k is not a perfect cube, if a plus b k cube root plus c k square cube root equal to 0, then prove that a equal to b equal to c equal to 0. I request you to do this as your home task and submit me. And in addition to this, I am informing you for this by this video we completed all the videos for the first chapter of your class 10th, and I think you most of you enjoyed the videos, and I request you again, please subscribe my channel, and thank you all.